Welcome back to AWS Cloud Services. Last time we saw how user talks to multiple instances through load balancer, and load balancer helps you to distribute the load coming from the users to all the instances we are going to configure in AWS. In previous session we also discussed about application load balancer, which is a type of a load balancer in AWS. With application load balancer, you can also configure listeners, where you can write multiple rules on the basis of path, header information, and hostname. In this example, listeners are configured in such a way on the basis of path/order product will be forwarded to target group 1, which has instance 3, and listener 2 is configured for /product info, which will be forwarded to target group 2, which has instance 1 and instance 2. And target group is nothing but group of instance, you can say. You can create multiple instances in multiple availability zones, that is subnet. In this way you can increase high availability. So in today's session we are going to do hands-on on this example. We are going to cover how to create application load balancer with configuration of multiple listeners with the rules, and also we are going to create multiple target groups which will be associated to application load balancer. To check our load is getting balanced on multiple instances, we need to create a application with multiple endpoints. So for this, I'm going to create an application by using Spring Tool Suite. You can create endpoints in any language, but if you're going with Spring Tool Suite, there are plenty of videos are available. It will guide you through how to set up Spring Tool Suite, Java and Maven on your machine. And I suggest you to go through those things and you can resume this video. After opening this tool, you can click on Create New Spring Starter Project. Here I have 1.8 installed on my machine, Java versions that to be declared in this dropdown, and build type would be Maven here, and I will be giving name AWS ALB demo. Click on next. In this wizard we need to select our dependency, so we are going to select web dependency here. So Spring Web come up with Tomcat container in it. We don't have to set up Tomcat container on our instances. Now click on next and click on finish. It will take some time for first build. After building successful, you can expand this project. Expand src main Java, right click on first package. To create a new package, right click on package, go to new and select package here. You can give a name here, .roller, and click on finish. Here you are going to create a controller class. To create it, right click on it, go to new, select class. You can give a name here, main controller, and click on finish. Annotate this class with annotations, REST controller and request mapping. While configuring load balancer with their target groups, there is a configuration of health check, and for health check we have created this endpoint, that is /product health. Private IP address of an instance will be the response of this path /product health. As we saw in example, we are going to configure path in such a way that it will be forwarded to target group 1, which has instance 3, and instance 3 will be in different availability zone to increase our application's high availability. We also have created get product info endpoint for our application. So in this way we have configured our endpoints. You can run this application on your local to test it. So go to your application in Package Explorer, right click on your project, go to Run As and click on Spring Boot app. So you can see it in console that application has started on 8080 port on Tomcat. So to test the application, go to browser, place your URL and hit enter. It's giving response as expected. Now it's time to build this application. To create a jar, that will be deployed on multiple instances we are going to create in AWS. So go back to your STS, right click on your project, go to properties, click on this location icon. It will open the application folder. Go to your application. To build this application, click on top navigation, type cmd and type mvn clean install, hit enter. It will take some time for first build. As soon as you see the build success, go to your folder location, open the target folder, it has been created. Now you can see the jar is created with the name of project. Now here our application is ready to deploy on multiple instances. So we need to create instances on AWS first. Log into your AWS console, click on EC2. As you can see, we don't have any instances running previously. So click on instances and click on launch. Here I'm going to give a name instance 1 for first instance, and my Amazon machine image will be Amazon Linux 2 AMI. Scroll down and my instance type would be T2 micro, which is also free tier eligible. I'm going to keep common key pair for all the instances. To create it, click on create new key pair. I'm going to give a name common key instance. Select ppk because we are going to use the putty tool. Create key pair. As soon as you click on create key pair, the key pair will be downloaded. Keep it in some safe location and do not share this key pair with anyone else. Scroll down. We will be in same VPC. So we are going to create a instance in particular availability zone, that is subnet. So there is no preferred subnet that has selected by default. To edit this, click on edit, click on subnet dropdown. So there are multiple availability zones for Mumbai region, that is 1A, 1B and 1C. For now, for first instance, select 1A. Now scroll down in security group. You can create a new security group that I'm keeping for throughout all the instances I'm going to create in AWS. So select create security group, give a name for it, instance SG, that is security group. I'm not going to change any description. For now, I will be keeping the same rule. Later on, we can change the rules. Now scroll down, click on advanced details. In bottom of this section, you will see the user data. AWS will execute the commands you have defined in this region. In our case, our application is going to run on Java. So I have these 4 lines of scripts which helps to install the Java while preparing instance for me. The first line which shows that these are bash commands. In second line we are going to give a permission. In third line we are going to update yum, and in fourth we are going to install Java 8 version with the help of yum command. Now click on launch instance, click on view all instances. So instead of waiting for this instance to be prepared, we can go ahead to create second instance. So click on launch instance. Here I'm going to give a name for second instance, that is instance 2. I will be keeping same AMI, that is Amazon Linux 2 AMI, and my instance type would be T2 micro again. Click on drop down, select common key instance, go down, click edit, select same availability zone that we selected earlier for instance 1. So instance 1 and instance 2 will be in same availability zone, that is 1A. Scroll down in firewall security group, click on select existing security group, click on drop down, select instance security group that we have created earlier for instance 1. Now scroll down below. Now click on again advanced details, go to user data. Now again place same script that we have kept for instance 1. Now click on launch instance, go to view all instances, and to create instance 3 again click on launch instance. We are going to give a name for instance 3, instance 3. The same Amazon machine image will be Amazon Linux 2 AMI, which is free tier eligible again. The type of instance will be T2 micro. Select same key pair that we have created earlier. Scroll down. Now click on edit. So now this instance will be in different availability zone. To select the different availability zone, so click on 1B here. Scroll down. Click on select existing security group. In drop down menu, select instance SG. Scroll down, click on advanced details. Again in user data you can keep same script to install Java while preparing instance for you. Click on launch instance. In this way you have created 3 instances. The instance 1, instance 2 will be in same availability zone, that is AP South 1A, and instance 3 is in separate availability zone, that is AP South 1B. Now to deploy the applications on these instances, you need WinSAP tool. Open the WinSAP tool, and with the help of this WinSAP tool, you can move your jar to your instance location. And also you can SSH into an instance to start the application. There are plenty of guidelines are available how you can install WinSAP. You can go through those things and resume this video. Here it is asking for our host name. So go to your instance, copy your public IPv4 address of instance 1, go back to WinSAP, place your public address, and in EC2 instances we have default user, that is EC2-user. So instead of password, we are going to configure our key pair that we have downloaded earlier and you have kept it in safe location. So click on advanced, click on authentication, and click on these 3 dots and select key pair that has been earlier downloaded from the safe location. Click on OK. To save this instance, you can click on save, give it a name, that is instance 1. Click on OK. Now you can log in into an instance directly. Say yes to this prompt. Here you can see you have logged in with instance 1. On left hand side you can see your local folder locations. So go to your applications target folder location. You can see this jar that we have built. Drag it and drop in into an instance location. Now moving jar is completed. So we have successfully moved this jar, but we need to start this application. And for starting this application, we need to SSH into an instance. To SSH on this instance, click on this Open Session in Putty. Here if you do ls, it will show you the jar you have moved earlier. And to run this jar, you need to do java-jar and your jar name. Hit enter. This will start your application on this instance 1. So in the same way, we need to do it for instance 2 and instance 3. To set up the application for instance 2, copy the public address of instance 2, go to your WinSCP application and click on new session, click on new site, place your host name, that is public address, and ec2-user will be our default user. Click on advanced, go to authentication, click on these three dots, select same key pair that earlier we have selected for instance 1, and you have kept it in safe location, I guess, and click on OK again, click on save. For our understanding, you can give name instance 2, click on OK and click on login. Say yes to this prompt again. Drop this jar to your instance 2 location. To start this application, click on Open Session in Putty. Do ls to confirm that our jar is moved successfully. And to start this application, java-jar, our jar name, hit enter. Now our application is also has started on instance 2. Same way we have to do it for instance 3. Copy instance 3 public IPv4 address, go to WinSCP, select new session, new site, place your host name, ec2-user will be our default user, click on advanced, select authentication to select our common key pair, click on OK and click on login. Say yes to this prompt. Drag and drop our jar. And to start this application, click on Open Session in Putty. Do ls to confirm. Java-jar and with our jar name, hit the enter. So our application has been started for all our instances. To confirm it, copy the public address of any of instance. Open new tab, place your public IP address :8080 slash product slash product health. So it's not showing you any response. This is timeout issue. So we need to cross check security group of an instance again. So go to our security group, click on instance security group and click on edit inbound rules. Here you can see the 22 port is allowed for an instance, but our endpoints are running on 8080 port. That we have to configure here. To add a rule, click on add rule. The custom TCP will be as it is. Keep your port name where endpoints are running. Click on your source, select anywhere from IPv4 address and click on save rules. So go back to your tab which was not showing any response. Refresh it again. Now you can see the response from the instance. You can see the IP address which ends with 157, that is private address of an instance. You can check this private address in instances. So go to our AWS console, go to instances. Here you can see the instance 2 has this private IP which ends with 157. Now the real picture starts from here. So we are going to create application load balancer, and these instances will be registered with the target groups, and target groups will be assigned to application load balancer. To create a load balancer, click on load balancer. You don't have load balancer till now, so click on create load balancer, and here you can see the multiple types of load balancers are available in AWS. For now we are going to see application load balancer, so click on create, give a name mylb. So you can say the application load balancer will be single point of access to all of users. For this you need to select internet facing, select IP address type IPv4 as it is. Now scroll down, so everything will be in same VPC as expected. And while creating multiple instances, we selected multiple availability zones, that is AP South 1A and AP South 1B. Select those availability zones, that is subnets. So AWS will fetch all the instances you have created in these availability zones. Now scroll down in security group. You have to create a new security group. So click on create new security group. It will open in new tab. Give a name my load balancer SG. I'm going to keep the same as a description. So as we discussed, the load balancer is going to be internet facing, and user will be talking to instances through the load balancer. So we have configured endpoints with 8080 port that we need to configure in this inbound rules. To add the rules, click on add rule. So type will be custom TCP as it is, and port range will be 8080. Select source as anywhere IPv4. You can say inbound rules is nothing but incoming traffic towards this load balancer. And if you scroll down, you will see outbound rules. And outbound rules are nothing but the outgoing traffic. Now scroll down, click on create security group. So go back to your load balancer wizard and click on refresh, and in drop down you will be able to see my LBSG, that is load balancers SG we have created earlier. Select it. You can delete this default security group. Now scroll down. Here you will see the listener configuration, and our endpoints are running on 8080 port. Same we need to keep here again. And here you can see you need to assign the target groups, and there are no target groups we have created till now. To create the target group, click on create target group. So our target group will be group of an instance. So we will be choosing instances here. Now scroll down, give a name, that is my first TG, that is target group. I'm going to keep as a name, and my port will be again 8080. It will be in same VPC, and scroll down. Here you can see the health check configuration. Here you can give our health check endpoint we have configured in application, and click on advanced health check settings. Scroll down. So we will be going to select the traffic port as it is. We are not going to override any port because our health check path is running on 8080 port itself. Here you can give health check threshold. Healthy threshold is nothing but The health check path will be triggered 5 times continuously, and if it gives the successful response, then it will be considered as a healthy instance. In same way, you can keep unhealthy threshold, that will be 2. That means in how many times path will give the bad response will be considered as an unhealthy instance. Here you can give a timeout. Timeout is nothing but the response time of our health check endpoint. Now scroll down. Interval you can keep 30 seconds. Every 30 seconds the health check will be happen and the success code will be 200. Now scroll down and click on next. Here this wizard is asking you to register the instances for this target group. For this my first TG target group, I am going to register with instance 1 and instance 2. Make sure here port will be 8080 again and click on include as a pending below. Now scroll down and click on create target group. So you can see the target group has been created, but that target group has not been associated with any of load balancer. To associate with the load balancer, go back to your load balancer wizard, click on refresh and click on drop down. You will be able to see the my first TG, that is target group we have created earlier. Now scroll down and you can see all the summary while creating this my load balancer. Now scroll down, click on create load balancer. You can view the load balancer. Now to cross check our load is getting balanced or not. So go to your load balancer and scroll down. You will be able to see our DNS name. Copy this DNS name. In browser, open new tab. Place your DNS name with colon 8080 port slash product slash product health is our health check endpoint. Now hit enter. You're able to see the response here. That means that our instances has been registered with this load balancer successfully. To see this IP address changing, click on refresh. Now you can see our load is balanced with instance 1 and instance 2. The IP address is changing, sometimes ends with 157, and if you refresh and here you can see it ending with 60. To confirm this, you can go to your EC2 instance, click on instances, and you can see the private IP address of instance 1 which ends with 60 and instance 2 has a private IP address which ends with 157. Now our instance 3 is not registered yet. So by this diagram we discussed about the instance 3 will be in separate target group and we are going to configure the path slash order product in such a way that it will be forwarded to instance 3. To do so, we need to create a separate target group for this third instance. Go to target groups. Now click on create target group. Again, we are going to select the instance here as a type. So I'm going to give a name my second target group and my port will be 8080. So we will be in same VPC. Health check URL will be same slash product health. Now scroll down, click on next to register our third instance. Now here you can see our third instance is available. Select that. Make sure your ports and click on include as a pending, and you can see our third instance has been registered with this second target group. Create target group. You can see that second target group is not associated with our load balancer. To associate it with load balancer, click on load balancer and go to listener. Scroll down. Here you can edit, view and edit rules. Click on add rule. Click on insert rule. Here you can add a condition on the path. So our path will be slash product slash order product. Here in on right side it is asking for to put an action. So click on add action, click on forward to. Here you can select our second target group which has instance 3. In summary you can see that if user hits this end URL, that is slash product slash order product, it will be forwarded to our second target group, and which has instance 3. Indirectly, you can say the instance 3 handling only this endpoint, that is slash product slash order product. Now you can click on save. You can click on back to load balancer once again. Now go back to your DNS URL, change your endpoint to order product, hit enter. Now you can see the response, which shows you the host name, that is private IP address of instance 3, and you refresh multiple times, it will go only to instance 3, that is second target group. The IP address which ends with 231, you can cross check with instances. So go back to your instances. You can see the IP address which ends with 231, which is private IP address of instance 3. To add more security to an instances, we can configure a security group of an instance so it will accept only the request coming from application load balancer. To do so, go to security groups again, go to your instance security group, edit inbound rules, that is incoming traffic towards our instances. Here you can remove earlier rule we have added. Now again add rule. So custom TCP will be as it is. Our port will be 8080 and source will be IPv4. Again, you can remove this zeros configuration, and instead of this one, you can select your load balancer security group. In this way, it will accept the request coming from the security group of a load balancer. Click on Save Rules. To verify that we are not able to access the instance directly, go to your old tab where you have kept the public IP address of an instance with the path and try to refresh. It will not show you any response. It will be a timeout. On this timeout, it will show you this response that this site can't be reached, and go to your load balance DNS name and you can refresh. So this DNS name is working with all our endpoints. This is how you can configure your application load balancer by increasing high availability by choosing multiple availability zones. That's it for this session. If you have any queries, please comment down below. If you understood this concept, please subscribe my channel. If you like this video, hit the like button and share it with your friends. See you in next lecture.